So thank you guys for the introduction, and thanks for inviting FLUX to be part of this. As Paul mentioned, my name is Charlie, licensed architect based out of New York. Born and raised New Yorker, so it's kind of hard to take me out of there, but every so often I do kind of visit other cities. Been in the computational design world for about 10 years, give or take now. Headed up the efforts back at an architecture firm in a different lifetime, dealing with interoperability, complex geometries, and taking something complex and demystifying it. So the minute it's demystified, it's no longer complex, right? It's understandable. The minute we learned how to tie our shoelaces, it wasn't a complex topic anymore, right? And as we grow, we start to understand the complexities, and they slowly go wayside, and we're able to design better and better, essentially. So over the years, I've worked on a number of different projects, anything from the scale of an airport, this is Nanning, China, to the scale of skyscrapers. This is CITIC Tower, CITIC Headquarters in Beijing. It's stated to be the tallest tower in Beijing. I've also worked on things as small as a line of chairs. I was really fortunate enough to work with Bill Pedersen himself on developing these. And it's probably one of my most favorite projects. We're able to go from free-form design to documentation and essentially developing the G code to drive the fabrication equipment, which is pretty cool. So it's going from design to fabrication. It wasn't that easy, I'll be honest with that, but it was a nice little package. I also teach. The last class that I was teaching is called the Algorithmic Space. Being able to, there's a play on space there, and the idea is to teach students how to write algorithms. So you're exploring the space of algorithms, but also exploring 3D space by writing algorithms. So trying to think a little more logically and a little more procedurally, essentially, and being able to take a number of different things. In this case, this is just an image, a 2D JPEG, and essentially being able to pull it apart based on color variation and see it from a different perspective. So that's enough about me. So I work at FLUX now, and FLUX spun out of Google X several years ago. Google X is kind of the incubator for a lot of their research, the autonomous vehicle, Google Glass, things like that. So we spun out a few years ago, and one of the things that we keep close to our methodology essentially is the same methodology that Google X has, essentially trying to identify huge problems and use breakthrough technology to come up with radical solutions. The AEC industry has always been adapting solutions from the nautical industry, the aerospace industry, the automotive industry, and we've adapted them fairly well, but we're at a point where technology is changing at an increasing rate. So therefore, we should start to think about developing technology specifically for our industry, as opposed to waiting to take other technologies and adapt them for us. And that's kind of where FLUX lies. So with regards to who is FLUX, this is a pretty good swath of a cast of characters there. There's some software engineers, some application engineers, a couple of architects, laying around here and there, some designers, some structural engineers, some with a focus in MEP. So we have a nice little swath of the AEC industry. I'm sure there's still more that that could add to the knowledge flow. So essentially, what is FLUX about? I mean, it's probably been murmured around here and there, different blogs, different websites, and so on. FLUX is essentially this platform where we can transfer data and geometry across multiple applications. So we're all familiar with, a lot of those file extensions that you see on the far right-hand side. With file formats comes proprietary applications. There's metadata built into some of these files. There's metadata that gets lost from these files when you're transferring back and forth, right? We've always taken, say, for example, an email and you copy and paste it into a Word document and the formatting goes awry, right? That's because there's metadata built into it that gets lost or gets aggregated within that even simple gesture of copying and pasting simple text characters, right? So imagine a 3D model where there's embedded attributes and parameters and materials and textures, and just imagine all the things that can go horribly wrong, right? and we've all experienced them at some point in time. So the idea behind Flux is essentially to share the data that we want from those specific files to the specific applications that we need. Data is a little ambiguous as a word, and when you feed Google data, you get some random image, kind of like what you see here. Again, it's just as ambiguous as the industry puts it out there. But with regards to data, what is it relative to design? So just as you see, just the simple profiles of the chair that I showed you earlier, this is what we see as individuals. But this is essentially the data behind those freeform curves, right? And some of this data is basically driven from whether it's fabrication constraints, whether it's design constraints. It can be a number of different aspects, right? So how can we take this data and preserve it as we move from one application to another, from one source to another, right? So with regards to Flux, there's 4 different topics that we're going to talk about, and I'll show you where and how Dynamo integrates to a few of these. The one topic that most people are familiar with regards to Flux is the plugins. And essentially what you see up there essentially are the icons for most of the plugins that we have available today. With the exception of AutoCAD in yellow and 3D Studio Max in purple. Those are coming out in the next few weeks. We also have Google Sheets, which will be coming out shortly. Just as we want to seamlessly transfer data across various applications, we also want to integrate pretty seamlessly into the application. So what you see here is just a small sampling of how we integrate into the application. So if you're familiar with SketchUp, it's just a simple toolbar with a handful of buttons, no different than most of the toolbars that you'll see on the SketchUp side. If you're in the Grasshopper world, we have very similar components to what already exists. If you're in the Revit world, same thing. You have your ribbon with your buttons. 6 buttons, 3 of which, one is a login, 1 is help, 1 is about. So the only 3 that you really need to know are the 3 in the middle. So learning 3 buttons is way a lot easier than some of the other plugins that you'll see in the Revit and Dynamo environment. We can do a number of different things, taking tabular data across various platforms and doing it and being able to do it in real time, such as this, just taking, again, some color and some data from a spreadsheet and being able to affect a design in the Rhino Grasshopper environment. And essentially what's happening behind the scenes is that there's a spreadsheet that's being fed up through Flux, it's getting queried, the data is being brought back into Grasshopper, it's being processed, and the model in the Rhino world is being updated. We could do similar things such as take massings from the SketchUp environment, shoot them through Flux, generate floor slabs outside of Revit, and then populate native Revit floor slabs within the Revit environment. And in this case, we're merging different data sets. So we're syncing this spreadsheet, and we're syncing a massing model from the SketchUp environment, sending it through to Flux. And then in the Flux environment, I'll show you a little earlier, we have this node-based application where we can take those 2 data sets and sync them together. And then we can push data into the Revit environment. When people think about interoperability, they always think about going from one application to another. And it's very rare that people talk about interoperability between the applications themselves. So because we make our data very lightweight and we essentially neutralize it, we could actually go between the applications themselves. So this is just a quick little example of taking level data from one application to another. I know in the real world we'll never do this. We'll always have a central file level data and we'll always lock that down so no one accidentally moves things or things to that effect. But it starts to think about being able to develop not just unidirectional path of data transfer, but also bidirectional path of data transfer, right? So we can take things in and we can push things out, right? And when we have that data transfer going in and out, there's moments where there may be data that's overwritten, right? And we don't want to essentially overwrite data accidentally. So what we've done is we've developed this dialog that pops up. And this is a situation for that example of the levels, where when the data starts to come in and it already exists within the Revit environment, it'll go through and look for discrepancies within the data that's coming in, data that already exists, and it notifies the user. So we don't try to automate the user. We don't want to automate the designer, but we want to augment them. We want to give them the ability to quickly identify what has changed and what has not changed, and whether or not to accept those changes or not. So the dialog, very similar to this, will pop up. It'll say, in this case, it was the levels that have changed, and in this case, it's identifying specifically that it was the level height that changed. If it was the family name that changed, the family name would be identified. If it was, for example, a floor slab thickness or a parameter type or something to that effect that changed, that will show up in this drop-down list, and you'll have the ability to click yes or no and identify which data you want to merge into your file. By being able to go, bidirectionally between various different applications, we start to rethink the concept of collaboration. We've all seen, Grasshopper and Dynamo files very similar to this, where everyone just kind of nicknamed them, the spaghetti file, right? Where it's just a series of wires going all over the place. But being able to go between the applications themselves, it gives us the ability to take that spaghetti mess in Dynamo or Grasshopper and essentially split it up. So you can have people working on your massing, you could have people working on your interior layout, you could have people doing your area studies, you could have people doing your facade studies, and essentially being able to transfer data across between one another without having that singular file that does everything, and having that singular individual that if he's out of the office, or if he's too busy, or if she's on vacation, or if they're under too many deadlines, that no one else can get into the project and essentially function, right? So we're able to take tasks and subdivide them amongst various different files and various different file formats. Again, in this case, it's going bidirectionally. In one side, you had an individual manipulating the massing. The person on the right-hand side was receiving it, cutting areas, and then sending the mass accumulation of those areas back, right? Just as we could do it between Revit and Grasshopper and Grasshopper, we could do it between Dynamo and Dynamo, right? Same thing, we could do the massing in one environment, and in the other environment, we could start cutting floor slabs and calculating areas. And in this case, what we're doing is actually we're merging data, right? So we're taking the massing from one side, we're taking the stacking chart from another side, and taking those two data sets and pushing them into a new Dynamo file. We could do things such as, control geometry back and forth. In this case, we're taking a freeform surface from one environment, and then using Dynamo on the back end, we're able to manipulate adaptive components in the Revit environment. Not only can we manipulate the geometry, but we also can manipulate the parameters within the geometric elements. So in this case, the adaptive components have a scaling factor that will scale the aperture. So as we move that little control point on the left-hand side around, you'll see those panels update. Now in the real world, we'll never really design a building this way, right? But think of that control point as if it was a solar radiation study, right? Think of it as if it was a daylight study or a Waldron diagram or a sky exposure study, right? Where you're starting to identify how much light is being received within a building. And now you can take that data, take those results, and push them back into parameters within the Revit environment to start to identify what glass types you may need, how many fins or louvers you may need, and things to that effect. And in this case, it's a simple, unidirectional setup, going from one environment to the next. We can take preform surfaces and essentially populate them within Revit families, and then you can take that Revit family, push it into or load it into a Revit project, and you can host system families on it. So now you can take simple, system families and host them on more complex geometries, and essentially have those update as well. When you update the family and reload it into the Revit environment, the associativity between the family and the system family gets lost. So you just have to click on the family and then click rehost and then re-click on the surface. That's kind of like one of the things that we found with updating families in the Revit environment. And again, it's just a unidirectional setup. This is my attempt of trying to show some pride to Chicago architecture. Please don't laugh or throw tomatoes. But essentially, you could take something that is modeled in the Rhino environment and just using Grasshopper and Dynamo, in this instance as a portal to essentially take a massing from one world, marry it up with a stacking chart in the Excel world, and essentially cut floor slabs within the Revit environment. And they're native floor slabs that you could post balls and cut plans and so on and so forth, right? In this case, what we're doing is taking native Revit elements with a series of built-in parameters into them. And we can essentially start to take the data from those elements and schedule it the way we want, and start to now take data from other sources and add them to the schedule. So you may have a data set that's coming from the architecture side. You may have a data set that's coming from the engineering side. You may have a data set that's coming from the consulting side, and you may want to essentially compare these three data elements across one another, whether it's the structural column, the architectural column, and the column enclosures or column finishes or something to that effect, or whether it's the equipment within a room or something along those lines, and you want to marry it up with other equipment schedules that you may be getting from other locations, right? And you can do this through the Flux environment. This is a simple flow diagram of essentially what's going on there. Freeze? No, cool. So with regards to Dynamo, what do you need to know? We've kind of kept it really simple. There's only 4 components that you really need to know. The first one is called flow control, and that's essentially identifying whether or not, identifying the frequency of when data is sent or received. So when it's in once mode, what happens to me is that data gets sent once and doesn't get sent again. When the data changes, it'll ping the user and say, hey, listen, there's data that's been changed. Do you want to send it or do you want to receive it, right? So you don't always have to be sending in constant mode, right? You may be making tens of design changes within an hour, and that person on the receiving end doesn't necessarily need to receive all those design changes, right? Once you finally identify what your design change is and you're happy with it, then you may want to send it over, right? So that's the once mode situation. There's also constant mode. And constant mode is that whenever a data element has changed, it'll know to receive it or to send it immediately, right? So it's not always checking. It doesn't always have a live connection, but it's always listening to that piece of data element. So you don't have to worry about like internet bandwidth and things like that. The one below it is essentially the Flux project, right? So it's just a simple drop-down menu. Select your Flux project from there. And then on the right-hand side, the other 2 components are basically identifying if you're sending the data to Flux or you're receiving the data from Flux, right? The keys are your data keys, and the mode is whether it's in once mode or in constant mode. And if you're sending data to Flux, it's what are you sending? Are you sending services, floor slabs, areas, tabular data, whatever it is. So it's kind of easy. We kept it as simple as can be. As I mentioned earlier, in the Revit environment, we got 6 buttons. Really, the only 3 that you need to know are the second, third, and fourth one in from the left, right? The login is kind of easy. And again, this is, to Flux, from Flux, and then the manage essentially opens up a side panel that you can dock in your Revit environment. All of this is built on top of a platform, and in order to transfer that data across from our applications to the Flux platform, it's eventually translated into JSON. JSON stands for JavaScript Object Notation. If that sounds too complex, don't worry about it. It's handled for you. It's in the back end. You don't have to worry about it at all. The great thing about it is that it's actually partially human readable. So you can actually see the JSON file and start to understand it. If it's a line, you can then identify the 2 points, and that's X, Y, and Z, and so on and so forth. If it's a polygon, if it's a NURBS curve, if it's a spline, whatever it is, right? You can start to identify that a little more. Once you log in to the web environment, which you don't always have to, right? You could always just go from plugin to plugin and just call it your day. But if you want to go a little further in depth, you could log into the web environment, and what you see here is essentially all your Flux projects, right? And if you notice, some of them on the lower left corner have initials, and those are essentially the individuals that you've invited to be collaborators on your Flux project, right? These collaborators can be invited in one of 2 ways. It's very similar to Dropbox. You can invite people in read-only mode, right, where they can read the data and not necessarily push it back up, or you can invite them in an edit mode, right? They could read it, make the changes, and push it back up, right? The great thing about this is that because it's cloud-based, you can work with anybody in your office. You could work with anybody in multiple offices if you're a global firm, or you could work with multiple people that are project stakeholders. So you don't have to worry about firewalls or FTPs or logins or anything like that. Everyone kind of can come to this location and start to manage it, right? So you could have your structural engineer in one location, your mechanical engineer in another location, you could have your contractor in another location, and they could start pushing and pulling as freely as they need. Sounds almost like a honeymoon, but I know projects aren't that smooth. When you go into a Flux project, this is essentially what you see. On the left-hand side, you have this list of all the data elements that have been sent up to Flux. And we try to identify them with an icon based on which application they've come from. So if you look at the lower two, they have the red SketchUp icon, the one above it is the Excel icon, and the other four above it are essentially data elements that have been created in the Flux environment. So you can take elements from various different applications, start seeing that data, start manipulating it, whether it's extracting areas or lengths, or taking a schedule and associating it with various pieces of geometry, syncing those together, and then pushing it out to another environment, right? So each one of those data keys essentially tracks history. So everything that goes through the Flux environment is timestamped. So we can start to identify when that piece of data was sent over, time and date. We can identify who sent it. We can identify which file it came from, how much data was sent, and also who consumed it. Right? So it's a nice little track record of what's been going on over the course of this data element that got sent over. The data is yours, it's not ours, right? So this is what we talked about when you see the JSON representation, but you could also view the geometric representation. So if you want to peek under the hood a little more, you can totally look at the JSON. You can download it, you can edit it, you can do whatever you want with it. It's yours, again, it's not ours. You can start taking data from various different sources. So in this case, we're taking a massing from one modeling environment. We're taking context from another environment, which I'll show you in a little bit, and we can start to overlay those on top of one another. So we've all taken drawings and models from various different sources, and file import, file export, do this, do that, this tolerance, move to that origin. We've all done this before, right? So if we all sync up our origins together, we can start pushing things to Flux and just start overlaying them here, and not have to worry about, oh, let's do a save as and throw it as here and then delete that file. It makes life a little easier. Within the web environment, we also have this node modeling application called the Flow. It's very similar to Dynamo and Grasshopper. There's these little blocks you can plug in on the left-hand side, and you get results on the right-hand side. The cool thing about this, there's actually a few cool things about this. One of it, since it's on the web, you can access it anywhere, right? So you could access it from here, you could access it from your office somewhere else. Your collaborators can access it, right? So if they're both logged in at the same time, they could see who's clicking what and who's pushing and pulling where, and they could start to coordinate with one another. It's cloud-based, so anything that gets processed here is processed on a cloud node somewhere else. Way powerful, way more efficient computer than you'll ever have at your desktop because it's way more expensive. But since the cloud technology and the infrastructure behind cloud technology is so robust that those costs of those cloud nodes have dropped significantly. So you can have a way better computer for a significantly lower price. And the other cool thing about this is that if you notice here, there's just one big component. So if you double click the component, they shrink into these little blocks. So we've just expanded this one component here. This is essentially a component where if you give it all the inputs necessary, it'll actually create the data element for an object in Revit. So you can create Revit elements outside of Revit. As long as your Revit file contains the family to populate this data, it will. So that's how the FLUX Labs in the previous exercise were generated. The family already existed within the Revit environment, and what we essentially did was start to populate all this metadata within it. So the interesting thing about that history, you might be asking, well, it's good to see where it went, but how actually usable is it? we could also roll back in time. So say, for example, you made a design presentation today, and your client or senior designer or something to that effect says, oh, I really like what you had 2 weeks ago. Can we go back to that and really understand that a little better? You can dig through archive files, which is what we do today, right? Or you can essentially scroll back in time. What you see on the bottom is essentially this timeline, and you can see all the days when data was transferred through for a specific data key. And then what you see on the left-hand side is essentially all the different days where data was transferred. And if you open up each day, you'll see the points in time when data was transferred. So if you find the design decision that you like, you could take that and you could reinstitute it. So it's kind of like going back in time to going forward. It's kind of like a little play on the flux capacitor. There's a little hidden, Back to the Future joke in there. So just as we can connect applications together, we can connect to a lot of other things, databases, open source databases, internal databases that people may subscribe through, internal data sets that firms collect, things to that effect. If you go to our labs page, you'll see a number of different exercises that we've worked on, a number of different apps that we've put together. A lot of these have come from some of our internal hackathons that we have. Every so often, we'll take a day or two to kind of like unplug and work an idea that's been brewing up in the back of our head. And this is just a small collection of them. As they start to come out, we actually have kind of like this little internal judging and internal contest of which one's the best and most efficient and so on and so forth. And those usually make the cut. So one example is the FLUX site extractor. And what this is doing is essentially going out to open source databases. One of them is OpenStreetMaps. The other one is a NASA database where they're essentially scanning the globe and essentially mapping the topography of the land, right? So we can go out to those databases based on the location that you've entered, and we could start pulling in all of this data into a singular environment, right? And now once it's here, you can bring it into Dynamo. You can bring it into Grasshopper. You can bring it into SketchUp, right? So we're making that data accessible. We're essentially surfacing it for you, rather than having to go out and write a specific plugin for Dynamo and get that data. And then you're in the Grasshopper world, and you have to write that same plugin all over again for the Grasshopper world. You can write it in just one environment and then now transfer that data back and forth. So sometimes you want to see the results of your data. And we essentially have a set of dashboard that you can start to assemble yourself. We have 3D viewports, we have bar charts, pie charts, tabular charts, so on and so forth. The cool thing about this, again, because it's online, you can get, once you put this together, you get a URL, and you can share that URL with your project team members or anybody, right? So if you're a project manager and you want to make sure that in the early schematic phases you're trying to maximize the FAR, or you're trying to make sure that you input all the programmatic requirements that the client is asking for, making sure that you're trying to meet the performer requirements or something like that, or if you're trying to track costs based on volume of concrete or anything like that, right? You can essentially start setting up your own dashboards to start to view this data. We also have early integrations with VR on the Unity side specifically. Unity is hosted in the cloud, and essentially you can go to our lab site, click on the Unity project, click on your Flux project, and start bringing in all these data keys from various different environments. So you may have a massing model from one place, you may have FLUX Labs from another place. Of course, in this world, if it's geometric data, it'll show up, and if it's tabular data or text or something, clearly it won't show up, right? It needs to be geometric for here. If you're curious about more of these labs, feel free to go to our labs webpage, labs.flux.io. If you want to peek under the hood and you want to see the source code, go for it. All of our source code is on GitHub. Feel free to go there. You can download it. You can edit it. You can make suggestions. And all of that, our plugins, our labs apps, our web apps, all of that is built on top of our SDK. SDK is short for Software Development Kit. There's a C# development kit if you're doing desktop development. There's a JavaScript development kit if you're doing web development, right? So you could access your data via web or via desktop, right? However you may like. This is just a small sampling of some of the apps that or databases that we've integrated with using our SDK. And we've done this on like a number of our hackathons. So starting from the left, we have a Google Cardboard integration, which is kind of, just a fun, again, was part of our hackathon, so it was kind of like fun and early. We have integration with Arduino, if anybody likes to play around with sensors and actuators and make things move and all that. We have integration with that, sending data through Flux. We have integration with GSA. It's a structural analysis application by Oasis. The fourth one in is Slack. It's a communication application. The last one is an open source health impact and materials database. So you could take your Revit model, start to query volumes and floor areas and things to that effect, and start to identify the common products within your model and start to see in real time the health impacts and implications based on that material. So if you're choosing, high strength concrete versus fly ash concrete versus a traditional concrete, what are the additives in the concrete that are essentially, and how does that affect human health? We have the typical channels. You can follow us on Twitter. You can go to YouTube and look up some of our videos and tutorials. We also have a community site where you can start posting questions, and look up other people's feedback, and so on and so forth. Earlier this year, we were invited to host a workshop at Facades Plus in New York. And I guess it went well because they invited us back to host a workshop in Dallas in a few weeks. So if you're interested, later on, or mid-October, October 13th and 14th, Facades Plus will be in Dallas, and the workshops, I think, are on Friday the 14th. And that kind of like puts it all together. We've gone through the plugins, we've gone through the platform, we've gone through the labs, and we've gone through the SDK. And essentially, I like to bring up the analogy that Flux is kind of the highway with these on and off ramps. And these on and off ramps land in locations, whether it's your desktop, whether it's a database on the web, where it's a database that you have internally. It could be anywhere, right? And it could be anywhere around the globe. And we could take that data and we could move it across various applications. So with that being said, I'm going to open it up to questions, confusion, thoughts, anything like that.
I have a question. You were one first. How are you dealing with the JSON files? The capacity that you're posting them? I mean, you show a couple examples. We know that some of the Revit files tend to get, very heavy. Mm-hmm. How do you manage all that data in the web viewer?
Yeah. So there's two things to that. One, we don't take the file. We just take the data that we need to take. Right, so a lot of the bloat comes from the Revit file itself. So just by extracting the data itself, we're already making that super lightweight. And as the person sends the data to Flux via the Revit environment, there's various different ways. They could select by family. They could just select the the mouse selection and all that. So whenever that goes through, it's significantly lighter than the Revit family itself. Our schema that we're using is super lightweight. It's as minimal as can be, and that's what makes it way faster.
So are you modifying the JSON file to the number of faces?
No, absolutely not. No, we don't touch your data. Your data is your data. If you've modeled it incorrectly, well, sorry, we don't fix that. We don't want to manipulate data. We want to transfer it.
You can manipulate that.
You totally can. Actually, to be honest, let's clarify that. We do not have access to your data. So if you told me, hey, I have this problem, can you help me fix it? I actually have to ask you to invite me to your project. I don't have access to it all. Everything's encrypted. We don't have access to it. So unless you invite us, we can't touch it. We can't help you. Things like that. Yeah.
Do you have file restrictions or many, project you have?
With regards to the number of Flux projects you have? No, not yet.
It's open to.
Yeah. Go for it. We haven't heard we're trying to find a better word than complaints. We haven't heard complaints about the number of projects, nor the size of data that has gone through. The only thing that we have seen, and this is, so we're always as strong as a platform that we live on top of, right? So we have seen a lot of data go through to the Grasshopper environment, to the Revit environment, and so on and so forth. And luckily, we haven't crashed any applications, right? But we have seen that sometimes massive amounts of data is being pushed to these applications, and these applications like Revit or Dynamo or Grasshopper just take time to churn away. And that's the host application itself and not us, right? We're just pushing tons of data, and the data just being received, right? It's like, think of the analogy of the highway, taking a 5-lane highway in LA, shoving it down to 1 lane, right? Everything's going to come through a crawl, but eventually it'll all go through, right?
The application that extracts the data from the NASA, got the building configurations. Have you done anything like that with like laser scan data and extracting geometry from laser scan data for like renovation projects or things like that?
We have not yet, but if you want to give us a call, we'd love to tackle that, see how that goes. Yeah, we'd be interested. We haven't, let me rephrase it, as far as I know. My colleagues might have gotten that request, but I have not dealt with laser scan data since I've been at Flux. I think that would be, we've had a few comments while we were here in Chicago this week about laser scanning data and photogrammetry and things to that effect. It'd be interesting to see how we can take that and essentially incorporate it into a very lightweight, seamlessly transferable.
Yeah, it tends to be really heavy.
Exactly.
So that's the problem.
Yeah. Yeah, I'd be curious to, you should shoot us an email with like a sample or something like that. We'd love to see how it performs, what we can do with it.
So following up on that, it works with the platforms that you specifically targeted and built an on-ramp or an off-ramp for to go with your analogy?
Yeah, but if you download our SDK, right, you can build your own app as well.
Well, maybe you can.
Yeah, it's interesting. So since we've released our SDK publicly, we have seen the adoption of almost 1 new app a day, which is, luckily it's only been a couple months, but if this continues, it will be quite alarming. But luckily, we also don't have to manage all of those apps. Like, it's your app, you built it, you manage it. We'll help you if you have questions and things like that. And the portal for the data transfer is there, so it's not a big deal.
I have questions. I think I a little bit just testing this one is from Dynamos to Flux, so I'm gonna change uploading the file to Flux and then see this one. But the concept that I understand is this kind of link between this kind of Grasshopper or Rhinos going to this Dynamo or Revit platforms, kind of changing the data together. But based on your presentation, my understanding that is only the kind of preliminary kind of geometry kind of data changing. It's not the complex data. Like if you just build up to maybe window data, can I just convert in the window, the components from the Revit into Dynamo? Can you do that?
Yeah, it's data. Yeah, everything that's digital is essentially data, right? And it could be broken down in the back end.
There's another kind of node there, and then you can just convert into the kind of Grasshopper's components, and then I can bring into maybe Rhino.
So, for example, you bring up the example of taking a very detailed, complex, Revit family of a facade or window element, and being able to bring that into the Grasshopper world. You can totally do it because in the Dynamo world, you can extract all that geometry, push it through to Flux, and then from the Grasshopper world, you can start to receive that complex geometry. Typically, most Revit elements are meshes, so it'll come into the Grasshopper world as a mesh. We don't force conversions of meshes to BREF meshes and so on and so forth. We do have components in the flow that allow you to take a BREF and mesh it and so on and so forth. But you could totally take that geometry and reinstitute it. One of the examples that we did for the Facades Plus New York event was essentially take a massing, subdivide it, push it into through Flux into Dynamo, populate adaptive components with a window frame and a glass pane and all that. And then just for fun, I took it back.
And then can I just also bring this all the kind of data? For example, if I just converting this my family objects from the Revit to kind of the grasshoppers that I needed to keep this maybe parameters data inside. Can I bring the parameters maybe set up to grasshopper?
Yes. So being able to take a geometric element with its attributes and transfer across, not a problem. The host applications need to be able to receive. And I know for a fact, because I've done this in the past, that Rhino will receive geometry and data. And you can save data elements within, or data attributes within geometric element and SketchUp as well. There's actually a number of SketchUp users that do that. The functionality of that is coming out in the near future. Don't quote me on the time, but it's coming out in the near future.
Okay.
I haven't had a chance to talk to our product guy in a couple of weeks because we've been across the continent. They're in San Francisco and New York. But that is kind of one of the things I want to essentially to move with our product as we move forward. And say not just geometry, but being able to take attributes. Once the AutoCAD and 3D Studio Max applications or plugins come out, we'll also be able to look into texture mapping, colors, lights, cameras, things to that effect.
The reason I ask is that some designers, they are doing the jobs on the kind of conceptual design on the Rhino and the SketchUp. It's a well-developed kind of idea, but I need to bring back into Revit one. But it's very hard to start it from the scratch on the Revit. It's kind of, I can bring this one with the data into Revit. It saves a lot of times. So if you can do that, that's great.
There's always, as buildings get more and more complex, walls are still vertical, floors are still horizontal, and we still source materials from the same vendors and so on. But buildings become more and more complex. Right? Sustainability constraints become more stringent. Building codes become more stringent. Safety codes, LEED, all these become more and more rigorous. And as these become more and more rigorous, and there's more and more specialties that are developed within our industry. And in order to provide for those specialties, there's going to be specialty applications, right? There's structural engineering applications for traditional, post and beam systems. There's structural applications for complex structural systems, bridges and tunnels and so on and so forth. And you can't say that, there's one structural application and that's it, right? Because no, there's many different structural types, tensile structural, compression structures, so on and so forth. So as these applications continue to grow, we still need to be able to bring that data back and make it accessible to individuals, right? We're going to have LEED applications and various different solar radiation applications and wall drum diagram applications and so on and so forth, right?
Yes.
And it's fair that there are these specialty applications and specialty databases, and because it's more knowledge that's being built up in our industry, right? It's our industry moving forward in a way. But we still need to bring that back because we still need to coordinate this data, right? We still need to, put floor slabs together and walls on the floors and finishes on these walls and so on and so forth. So that's kind of where we see things. We want to bring all that data back and forth between the applications. Yeah. I know there was one more question.
Yeah, it was actually kind of two, not really so much based on the technology of it, but I heard about you guys through Design Allies and specifically Brian Ringley. I noticed that you had something up there about it, but what's your guys' history? How did you exactly spin off from Google X? And then also, kind of what's your guys? What is it that you guys do in order to actually generate revenue, or because I know you said you guys release a lot of your information out there, and kind of what is your specialty in terms of generating revenue? Are you guys kind of like how Case used to be before they were bought, where you're kind of creating specialty plugins specifically for end users and clients, or is it more broad-based than that? Or
So, okay, let's tackle that as the two parts that you mentioned. The first part, how did we spin out of Google? That was a little before my time, so I don't know the full details, but the little bit of history that I do know is essentially that, it's identifying huge problems, right? And the AEC industry is, a lot of the projects in the AEC industry, if you're lucky, an architectural project is, a year to 3 years, right? I've worked on projects where they were 8 years and they're just massive, and by the end of the time, they drain the life out of you, even if it does go successful, right? Because projects are so long, adapting new technologies midway through a project is quite difficult, right? So therefore, it's almost as if the projects themselves hinder us from adapting new technologies. So there was a huge problem, being able to, keep up with the technological times, right? We all have smartphones today, right? 5 years ago, did we all have smartphones? Maybe. 8 years ago? Significantly less. 10 years ago? Probably not, right? So within just 10 years, the things that we have in our hands have changed. Just imagine the things that we live in, right, and how they change. And they're way more complex than just the little things that you have in your hand, right? So that's kind of where some of the concepts started to brew within or at least as I know, started to brew within the Google environment. There's like a lot that could be done. And we all kind of know this in a way, right? I was part of a computational design team at a different firm, right? And the reason why we had that is essentially there were efficiencies to be had within our industry, right? Sometimes, they say the definition of insanity is doing things over and over and expecting things to change. We do things over and over and we expect things to change. We expect things to be easier, but we don't do anything to make it easier, right? So we have to take the initiative, essentially. So with regards to the second answer, like how do we make revenue? So we're still a startup. We spun out a couple of years ago. We had some nice investments that went through. Again, I don't know the full history about Flux, but we do have enterprise-level customers. We do have billing in place. I know on our website we do have pricing tiers, and I know within the next month or so some of those are essentially going to be instituted with regards to making revenue to keep this initiative going. With regards to what is our secret sauce, it's the platform, the underlying platform. So if you want to think of how do you engage with Flux, think of it as kind of like a pyramid. At the very top level, you have the plugins. It's super simple. Everyone's very common to, the Dynamo and Revit and AutoCAD and all that stuff, right? Very simple thing. You could just use Flux that way. Never have to go to the web interface. Never have to write an SDK thing. Never have to go to a flow. That's it, right? You just do that. You can go a deeper level, which will give you a little more flexibility if you start using the flow, right? Transfer data through that, manipulate it, push it to other places, right? You can go to another level and use the SDK and start developing your own apps and link to your own databases, whether you're subscribed to a database or it's just data that you've aggregated internally, things like that, right? So your usage slowly starts to grow. And then underneath all of that is the Flux platform, where we track history and we convert everything to JSON and things to that effect. The cloud compute aspect of it, the collaborative aspect, all of that. So that's the underlying framework of who we are and what we can do. And then there's various different tiers built on top of it.
Because of that, I have to ask this question. So it's kind of, for example, the file that I'm working on is, Revit file is about actually minimum 100 megabyte or 200 megabyte. That if I needed to put it on then the Flux, how long it will take to be proceed. Flux. And it is not only file, it's I will have one of the SketchUp file, Rhino file, Dynamo file, Excel file. It's all kind of put it all together. And then try to mix them on the data on your Flux platform. So how can I organize this one? How fast I can do this one?
So to clarify something there, we don't take files, we take data. So if, say, for example, in your SketchUp file, you have modeled a building with floor slabs and walls, an exterior enclosure, roof parapet, windows, doors, things to that effect, you can take the entire thing, all the geometric elements, and push that up to Flux as a singular data key. You can take various elements, select all the walls and push that up, take all the floors, push that up. You can take things on various different layers, right, and push that up. So the way you send your data through to Flux is dependent on how you want to organize it, really. Just like it's dependent on you, on like what you put on what layer, similar concept, right? You organize that yourself. So you're not going to take, there are ways of taking the actual SketchUp file and throwing it into Flux, but then it's just binary and you won't be able to access it. So with regards to, being able to take your SketchUp stuff and your Revit stuff, you could totally do it that way. And by doing it that way, you're removing all the SketchUp bloat, all the Revit bloat, all the Dynamo bloat, even though Dynamo is, quite lightweight, it's, XML based and all that. But still, you're removing a lot of that, right? So you're taking the geometric elements, you're taking the attributes, it's as lightweight as it possibly could be. I forgot what was the tail end.
How fast?
How fast?
Yeah, I can put it. I can put it over there. I think it's 20 megabytes.
What kind of internet connection do you have?
It's a 41 maybe.
So yeah, it's all dependent on your internet connection. Yeah, I've done situations where, so my colleagues in San Francisco, I'm based in New York, I'm in Wi-Fi at home, he's at Wi-Fi in the office, and we could do things in pretty much real time. There's maybe like a second delay, but a second delay for 3,000 miles isn't that bad. It's not so bad. We've done another situation where both my colleague and I were in the same room, we were running guest Wi-Fi, and also projecting onto a GoToMeeting. So we had a GoToMeeting on my laptop, and then between my colleague and I, we had a Google Hangout session. So there's two VCs going on at the same time on my computer, and then we're both transferring data back and forth, and it was happening in real time. And the reason why we did it that way is that only I could be showing my screen during the GoToMeeting.
So geometry is kind of messy. Exchange is easy, but I think huge file.
Mm-hmm.
I don't want to just waiting time on the FLUX there. So.
Yeah, usually I've tried large data sets, typically facade stuff, because that's kind of like my background. So I've done that, and the transferring up to Flux and the transferring down isn't where I see issues. It's usually, when it comes down, it's usually the application churning away and processing that data. Again, it's a kind of like 5-lane highway that merges all into one lane, and that one lane happens to be the host application at times.
Flux at just the plugin level, are you still sending, you're sending a file of Revit, Dynamo, or whatever, are you going out to the cloud for that data?
Yeah. Everything follows the same path. Yeah. So you can take your Revit elements, push them up to Flux, and then go to somewhere else in your office or to another application on your own computer or something like that, and then pull it down from Flux. Yeah. So it's not, go find it on a server here, or it's, like link to this file or link to that file. It's up there. Because it's up there, you can link in various different locations, which is kind of nice.
Just some of our projects, we have
Confidentiality
agreements, and they get
Yeah.
weird about that stuff.
So everything that goes through Flux is encrypted. Everything to our system is, like I said, not only is it encrypted, but we also don't have access to it, right? So that's 2 levels of security. But we're also pursuing SOC 2 security, which is, I used to know the acronym. I wrote a 4-page document about it. I should know this. Service Organization Commitment Level 2, which is the industry standard for cloud-based computing and processing. So the Googles, the Dropboxes, the Amazons, all these guys go through that certification, and we're doing the same thing. It's a whole lot of red tape. There's a reason why there's a 4-page document I had to write. Yeah. And then we also have, whoever talks to us, we don't put that out there, whether we sign an agreement or not. Any other questions?
I think this is the best Q&A we've had at a meeting so far. I guess I'm going to take that as everybody's real interested in Flux. So.
Hope so.
Yeah.
Feel free to check us out. And there's our website. You can email us. You can follow us on Twitter. If you have any questions specifically, you can email me. My email's at the bottom. If you want to invite me for a beer, down for that too.
All right. Well, thank you very much, Charlie.
Thank you.